to introduce myself. I'm Srilalitha, and I'm application developer from same Thoughtworks Chennai. And I would like to share to you all an interesting concept that I came across recently, which is I'm not going to repeat the title. So it's a switch, like from one place where you could just cut down all the network traffic to your services in a specific AWS network, right? And the tool which I'm going to be using here today is GitHub Actions. But basically, this is just for the concept side, and you can use any tool to implement the concept. And I haven't done the entire sprint zero to develop a demo application for us, but I've made a miniature version of what is required for you to understand the concept. And and yeah, I am not going to dig deep into all the services that we will be using, but a brief overview of what is required for you to understand the concept. From that, the main service that we will be using is the VPC. Yeah. So VPC is basically the private network in AWS for us to host our instances, services, or any other applications. And subnets is basically the logical separations of those CIDRs in VPC. So basically, we can separate these subnets into private and public subnets. As the name suggests, right? We have certain private services like databases and instances that we do not want the external world to access it. We keep them inside the private subnets. Basically, they are not assigned any public IPs, and they are just accessible only within the private network. But if you take the public subnets, they have all these IPs which are publicly accessible. So hence the name. And we keep our instances, like for an example, load balancer, who we want the external world to give access to, or to the internet, right? And usually these subnets are split across different availability zones, so that even if one region goes down, maybe you can use the other region to give us the what is required. So, and the main heroes of this VPC network is the internet gateway as well as the NAT gateway. And internet gateway is used by the VPC to get access to the external internet and to the world. And the private subnets talk to the internet gateway, and usually via the NAT gateway. So these internet gateways and NAT gateways are AWS managed resources, and their scalability, availability, and everything is being taken care by the AWS. And usually there is one VPC associated with one internet gateway. And if you take the NAT gateway, just like how internet gateway is for the entire VPC, NAT gateway is for the private subnets to talk to the external world, right? So so you can imagine this like an introvert and extrovert. They are in the same restaurant, right? And you are in a table, and in case if the introvert wants to make an order to the waiter, right? What we usually do is we tell our extrovert friend our order, and they will be talking to the waiter to communicate whatever you want to eat, right? So it works in the similar way. So the instances of servers who are in the private subnets, if they want to talk to the external world, they will be using this NAT gateway, who is the extrovert, and they reside in this public subnet, and that's how they are being able to communicate to the external world. So, and they are usually attached an elastic public IP. It's basically an IP which doesn't change even if the server goes down and another comes up, so that the public subnet doesn't lose control over the NAT gateway, right? Another important concept is the route tables, and the routes are configured within the subnets. And I will show you a bit in the demo of how this works. But basically, each subnet has a route table associated with it, and if they want to communicate with another instance within their own subnet, then they will be using the local routes. And if they want to talk to another subnet, they will be using either one of the internet gateway or the NAT gateway. Yeah. And the next hero of our concept is the NACL. This is network access control list, right? This is like a firewall for one or more subnets. So you might have heard about the AWS security groups, right? How the security groups are attached to the Elastic instances, and how they act as the firewall for one instance, right? It's the same, but it's spread across the one or more subnets. And usually, security groups are stateful. If there is an incoming traffic, they remember it and they automatically allow the egress traffic. But NACL is stateless. So we need to explicitly allow or deny certain rules, right? The traffic to the system. And yeah, and usually they work hand in hand with each other. So whatever traffic is allowed by the NACL is further filtered by the security groups to access the instance. And NACL is basically rules based approach, and the last rule star automatically comes when the NACL is created. So usually when a subnet is created, if we don't create an explicit NACL, the existing NACL or the default NACL will be attached to the subnet, right? So what happens is, so there is two different rules, one to deny all the traffic and one to allow all the traffic. And so whatever the rule numbers is there, right? So it is usually the increment of 100. And why this matters is they decide they decide how the decision should be taken. They drive the decision. So basically, if there are two different rules, they are matching rules. And but which one to decide, like one has a different decision and other has a different decision, it goes based on the rule number. Whichever rule number is the lowest, that has the highest precedence. Yeah, and together they look something like this, right? So when the client tries to access our service, first it crosses the internet gateway to reach the NACL, and you can see that there is further filtering from the security group. And NACL is stateless, so you will whatever traffic you are allowing is not explicitly allowed the outbound way. So you have to explicitly specify the rules, and that has to match with your security group configuration as well. Now I'll quickly show you the demo for the same. So this is the VPC I have created for our demo, and you can see it's free. And I have two availability zones and three subnets, two of which are public. And you can see they are together bound by the route table and they talk to the internet gateway. And my public subnet, they talk to another route table which talks to the NAT gateway. I will show you the NAT gateway route table to understand this more clearly. So you can see the CIDR in which my subnet resides. So those traffics is directed towards the local target. But the other all CIDRs, basically 0.0.0.0/0 means all IP addresses, they are targeted towards the NAT gateway. Right? This is how uh, the VPC setup works, and our application looks something like. So this is our load balancer, and this load balancer has a DNS name allocated to it because it resides in the public subnets, as you can see. So they have public, I mean, it has the public IP associated with it, and it has the DNS name resolving for that. And if you hit the load balancer, then it further hits the instance that is running in our private subnet. So that's how our instance is being accessible from the external world, right? So via the load balancer. Okay, so any questions so far in our setup, how it looks like? Yeah.
First slide, you mentioned that the public subnet. So, sorry, but I don't have much idea about this, so it might be a basic question.
Sure, yeah.
So in the first slide, you had mentioned about the public subnet being part of NAT. Sorry, the private subnet. sorry, not the public, the private subnet communicates to the internet world using NAT. Is that
Yes,
right?
like this, yeah.
So is that like all the time or just whenever it's possible? Because you mentioned it usually connects to it through that. So is there a way that it mentions without the NAT, it directly connects to the outside world? Is there a situation like that?
No, actually, if there is a situation or use cases like that, we usually place it inside the public subnet. So basically, it's based on our requirements, how we want to design our instances, right? So for an example, if you take, you have your service, for an example, the same EC2 service is running inside the private subnet, and you want to talk to an instance like third party provider from where you want to fetch the data. So that will be through this NAT instance. So the traffic will go to the, so it's the third party provider or the other client that you will be invoking will be part of this other IP range, right? Then our instance will talk to the NAT gateway to get the data provided, and NAT gateway will in turn resolve our private IP and it will communicate with us. But this instance is not accessible to the external world.
Okay, thank you. And another question was the DNS part, which you mentioned right now. DNS
Yeah,
or
the load balancer.
yeah, the load balancer. So those are part of the private or the public subnet?
Public subnet, exactly. So whoever you want to access from the public via the public, right? So that is in the public subnets, as simple as that. If it has the public IP, like I can put the IP and talk to the service, then it's part of the public subnet. Then it has the public IP.
Okay,
Yeah.
thank you.
Thank you. Any other questions? Yeah. Yeah. You need the mic, right?
So I wasn't able to comprehend the things you mentioned earlier. So I just want to repeat all the stuff you had mentioned about this demonstration.
Okay.
Thank you.
Okay. So basically, so yeah, so this is our application, right? So at the end of the day, it's just a server where you host the content, right? So if you take my application, as soon as I hit the DNS, I'm going to get welcome to Geek Night Chennai. So, but the server where this content is running is inside the private subnet. Similarly to in your system, you will be hitting your local host, right? But if I want to see what's in your local host, then I have to type some IP and then your port where your application is running. But your IP is not accessible to me. So that's how it works, right? So you have to host it somewhere in a public IP where I can access your the content that you are launching. So it's just like that. So our instance is running inside a private subnet, and we need this load balancer service who resides in the public subnet. So our load balancer provides us the DNS name, which we can use to access the contents of the EC2 service, which resides in the private subnet. So this is how our architecture looks like. And this combination resides inside our service called as the VPC. VPC is just like a private set of services that we use for the internet in the AWS to set up our network configuration. So NACL is something. I haven't showed the network access control list, right? Yeah. So network access control list is like a firewall to all the three subnets, all the public, private, and all the range of IPs that I'm communicating with. That is basically protected by a firewall, and this is the idea of such firewall. And this has two rules basically configured in it, and one to deny all the traffic and one to allow all the traffic. if the incoming traffic does not match any of the given rules, then it automatically gets denied, because that's the basic rule, and that's the rule you cannot edit as well, right? So this is more like the firewall you have for the system. And yeah, and like I said, NACL is stateless, so you have to specifically specify where your incoming traffic is coming from and where your outgoing traffic is going. Yeah, you decide whose IPs you let your system access and whose IPs you want to access as well. Yeah, good so far. Cool. Yeah, sorry. Route table is the one that decides how your traffic should go. So you know where your traffic should go, but there needs to be a decider of whose DNS resolver you will be using, right? So all IPs does not reside in the same DNS resolver. So it's more like route table is a resolver.
Basically, from DNS to route table, from route table to
Yeah, it decides
subnet.
the route basically. You just split your
From load
traffic
balancer.
across. That's all.
That's what the load balancer also does.
Load balancer does that in a way, but it's more like a wrapper, I can say. Yeah, but this is like an internal implementation of how that works. Correct. Yeah. Yeah. You had
Can you just go to the previous slide?
slide. Okay.
So you told that via NAT gateway you can access the private subnet. So, I mean in this diagram. So, like, is there any other host we can define ourselves in order to access the private subnet? I mean the EC2 instance inside the private subnet. Like we can define anything.
Yeah, we can define something called as the bastion host. So that will route the traffic inside the to the designated EC2, just similar to what load balancer does, right? So basically, its concepts are the same, but it's been used by different services. That's all.
Yeah, thank you.
Okay. Yeah. Security groups, right? They go hand in hand with each other. If you want to block an IP from accessing your entire list of all the services, let's say you have a database instance and you have your Spring Boot application in an EC2, and they both reside in the same subnet. You want to allow traffic only to the Spring Boot application, and you do not want to them to access your database. This is actually bad practice. They should be separate. So just for an instance, I'm saying two different services. One you want to allow the access and one you don't want to allow the access. Then what you will do at the network access control layer, at the NACL, you will allow the traffic. And at the security group layer, you will deny that, allow the traffic. And for the database security group, you will deny the traffic. So the traffic goes only one way, and you are not able to access the database instance. You get what I mean? Yeah. So within so you can say it like security group is at instance level, like it's tied close to the instance. But NACL is more like the subnet level. Subnet is basically range of IPs. That's all. Yeah. Cool. Then we can continue. Okay. So that's another thing I wanted to show as well. So with the current setup, if we hit the DNS URL, we get the content. Welcome to GeekNight Chennai. And yeah, coming back to the topic, right? Why we need a kill switch? It's basically whenever we have such attacks like denial of service or distributed denial of service attacks, right? So you can see it from the system. A bot master will try to control, create different clients and bombard our service with a lot of requests. And we need to stop them first before we work or do a postmortem or work on the solution to protect our system. So we want them to stop at the access layer itself. So in those cases, we just go and restrict them at the traffic, restrict their traffic at that level. But this also gives us the flexibility to allow our own IP to test the system. You want to see some stuffs like whatever has been broken or something. For testing purposes, we can add our own IP, allow our own IP, and block the rest of the IP addresses as well. You can control it like that, which is what is my second point. So instead of taking an entire system online, you can just disable certain ports, IP ranges, or even the endpoints. So allowing the other partial functionality to continue, and this also helps the organization to enforce security policies to disallow any legal losses as well due to these attacks. And like I said, the tool I'm going to be using here is the GitHub Actions. And GitHub Actions is basically a CI/CD pipeline, just like your Jenkins or there used to be Go CD, and that's right. So GitHub Actions can also be used like there is an event, and then we get different runners to do different jobs, whereas you execute a series of steps. So I'm going to use the pipeline to trigger a job that runs a workflow to disable the network. You would have guessed by now, right? How we cut down the network traffic. It's basically by disabling the rule. That's all. I can show this in a quick demo. Just a minute where I update my credentials. Cool. You can see my screen, right? So this is where I have my temporary user credentials to do the job. So this is GitHub Actions, the CI/CD tool that I was talking about. And now I'm going to run the workflow for the kill switch network traffic. It picks the network ACL ID from the secrets as well. And you can see, right, both the rules are turned to deny, both the ingress as well as the egress rules. And now let's try accessing our application in a private window so it doesn't catch anything. You can see our application is not accessible now because we blocked access at the knuckle layer itself. Now I'm going to run the workflow to undo the same. Yeah. Now let's check our network ACL. Now it's turned to allow all the traffic. And you see our content we are now able to access our application. So what is happening inside this workflow is I get the network ACL ID from the secrets as well as the other AWS credentials from the secret. And what I do is just replace the network ACL entry, both the rules, ingress and egress, and I'll turn the actions, the decisions to deny for all the CIDRs. Basically, the rule number 100 that we were talking about. So that's how it killed the traffic. And when I did an undo kill, it just replaced the rule actions to allow. So that's how the application access was recovered again. Any questions so far?
Next up, when the attack happens, we know that a lot of traffic is being generated.
Mhm.
What is the part that is handling, but that is monitoring the traffic? Which part? And taking the necessary actions.
Yeah, that we'll talk about in a bit. Yeah.
Network ACL ID will change a static or dynamic one.
It's a static one. So like I said, if you want to create a network ACL for your different subnets, like one for each, you can create one and it doesn't change. You can keep it in your secret and use the same network ACL unless and until you do a redeploy. Only then the network ACL ID will change. Correct. You're right. Cool. Now, uh, yeah, yeah. Ingress is nothing but the incoming traffic, and egress is nothing but the outgoing traffic. So your IP is probably 127.7.7.7, right? Mine is like 127.8.8.8, and we both are in the public IP. I want to access yours, then mine to yours is egress, and yours to mine is ingress. With me as the, in my perspective. If it's your perspective, it's the opposite, vice versa. Yeah. Yeah. Yeah, like I said, it's just one tool that I have used. You can do it even in a more different ways. You can even provide a UI where you just click a button, like any product owner or business analyst, like any non-tech person, they want to just disable the traffic with one button. You can also do it. But basically, the concept is you will have to stop the traffic at the NACL layer. That's all with the AWS command.
For example, how common user security the access for like if it is going to be used from GitHub, can you have a track of that? Like who have done that?
Yeah, we can track that, right? We are able to see the actions. You can totally check it at the user level or system level, right? So if you take GitHub Actions, you can see it was manually run by Srilalitha. So I executed the script. If it's automated by some other, maybe CloudWatch alarm or something like that, then it would have the data. We can record the data. Of course, it's going to come by an incoming event, right? Some event is going to trigger this, and you can record that event.
Specific based on AWS user, or is it going to be based on GitHub Actions user? Like, do we need a username and password for GitHub, or it can be common for AWS?
Yeah, anything you do, you cannot do it without a AWS user, right? And you can even see the logs in the cloud trial, I guess, whatever the changes that has been happened to the network ACL layer or any event in the AWS ecosystem in your account, that can be tracked by cloud trial.
So for every access, we might have to pay for AWS, right? For every GitHub access?
It's a good question. I think it depends on the resources cost, but I am not sure how much it costs for the network ACL alone.
Thank you.
Mhm. No. Using an AWS CLI will not cost anything. It's just the resources you own. So I am running an EC2 instance for probably in 1 hour. Then I will be, I will be charged for that. So only based on the resources I use. So that's the benefit of the, cloud providers, right? So you are just, billed by your usage, billed by the resources you own. Yeah. Cool. So that's where I'm exactly going at, right? So similar to what you were talking about. So any tool can be used, and GitHub Actions is one that I'm trying to use. And basically, we also create a separate, IAM role as a GitHub Actions users, and we give only specific permissions, fine-grained access or permissions to do the specific task alone, to replace the network ACL ID alone. And that role, we can attach it to the workflow, and we can use that role to perform the action as well. Now I have used a temporary user credentials, but you can even use it with a more fine-grained approach. And yeah, to much more advanced approach, right? AWS Network Firewall is an AWS managed service by in itself that does this task in a more advanced manner. So it can handle more than one VPC peering, VPN connections, and all, a lot of premium connections. And it even does the traffic filtering and the flow logs of inspection. It does a more complex firewall as well. We can even use that. And we can automate the workflow by implementing the monitoring. We can analyze the patterns in which our system got exposed and got attacked. We can analyze such patterns, and we can train our system to monitor such actions and do this, perform this, solution by itself. We can totally automate this. And yeah, and this is just one layer of protection, right? Based on the instances or based on the attacks, we can even decide to even doing a kill switch to stop the instances, or a kill switch to even nuke everything in your account. So that is also possible. And it's usually a good practice to have one NACL for one subnet, so that even in the workflow that I was showing, you can iterate through the list of NACL IDs. Like what if I have 3 subnets and I have 3 NACL created for each subnet, I can iterate through the NACL IDs and block each one of them as well. So it's good to follow one NACL for each subnet. And yeah, and one more thing is, we modified an existing rule from the default NACL. What we could do is we could even add a rule with the lower value, which has the higher precedence. For an example, I can add another rule with rule number 50 or 40 or something like that, and I can deny all the traffic from there. And usually that will be taken the precedence over the other. So it is also possible. So these are some of the possible extensions, and of course the possibilities are endless and infinite with AWS, of course. With that, I have come to a conclusion. Okay, any questions? Cool. Thank you all. Please share your feedback, and please do coming for the upcoming sessions as well. There are interesting topics lined up. And we have networking and dinner. Probably our host will